Okay, it's 11 o'clock. And let's see, microphone's on. Looks like we are good to go. Whoa. There we go. Turn that off. Okay. So yesterday we worked on order of operations. Today we are going to work on long division. So not just regular division. We're not going to be just doing 4 divided by 2. We're going to work on some different strategies for long division. So these are division strategies. So we have 3 different division strategies that I'm going to go over. The first one is repeated subtraction. And repeated subtraction is basically when you just take a number and you like, let's say, for example, let's choose 20 divided by 5. We'll start kind of small here. 20 divided by 5. So what we're going to do is we're going to take the number 20 and we are going to subtract 5 from it. So we subtract 5 and we get 15. So I'm going to put a tally over here. I subtracted 5 one time. Then I'm going to subtract 5 again. I'm going to get 15 minus 5, which is 10. I've subtracted 5 twice now. And then I'm going to subtract 5 one more time, and I'm going to get 10 minus 5 is 5. So I've subtracted 5 3 times. Now I'm going to subtract 5 one more time because we're going to keep going until we get 0, which 5 minus 5 is 0. So we get 4 tally marks right here, as you can see. So 20 divided by 5 is 4. We can double check our work. If we do 5 times 4, we get 20. The way we could check that, if we do 5 and add it 4 times, 5 plus 5 is 10, plus 5 is 15, and plus 5 is 20. Notice 1, 2, 3, 4 5s. So that is repeated subtraction. That's how you do it. Now the thing is, this works great with small division numbers. However, this does not work with large numbers. Let's say your number was 6,742, and you wanted to divide by 2. Repeated subtraction is not going to work. It's going to take you forever to do this. So repeated subtraction, good for small numbers, not so good with big numbers, which is why we're going to move on to the next strategy. In fact, I'm going to flip the page for that as well. By the way, I hope you all are having a wonderful day. I had a nice little jog today, had a decent little breakfast. I'm feeling good. So let's keep moving. Okay, so we just did repeated subtraction. The next way to divide, another strategy, is you've heard of partial products. You can use partial products for division. So let's do partial product division. Partial product division is, let's say I'm going to make the number a little bit bigger. Let's do 100 divided by 5. Now, partial product division, yes, you could do repeated subtraction and get your answer with this. This number is still not too big to where we wouldn't be able to do that. However, there's another thing that we could do. So we're going to write our division problem. So it's 5 divided into 100. And what we're going to do is we're take the numbers 5 or 10. If you already know the answer, please don't put it in the chat. We're going over the problem in partial product. But what we're gonna do is we're going to pick a number that makes sense. Like it's just easy to multiply. If you're really good with your tens and it happens to be a number that you can do tens with. This is great. So what I'm going to do is I'm going to pick the number 10. So I know 5 times 10 is equal to 50. Now, because I know 5 times 10 is equal to 50, I can just subtract 50 right here. Okay, because division, it just involves a lot of subtraction. So if I do 100 minus 50, I get 50. What I'm going to do is I'm going to take that 10 and I'm going to put it right here, just so we save it for later, okay? Then I'm going to do, I see 50 right here, so I know I can do 5 times 10 again, so I'm going to subtract 50 again. 50 minus 50 is 0. We have our 0. We're going to put this 10 right here because we have to save it for later. Then what we do is we add these together. 10 plus 10 is 20, and if we do the math, we have 100 divided by 5 is equal to 20. Let's double check. 20 times 5 equals 100. We can even double check it with repeated addition. So 20, 20, 20, 20, and 20. Add all those together. Zeros across the board are 0, 2, 4, 6, 8, 10, and you get 100. Okay, so partial product division. However, I'm going to do one more problem, maybe one that's a little bit more challenging. So let's do 112, 112 divided by 3. Again, I'm just making these numbers up off the top of my head, so I don't know how they're going to turn out in the end. However, let's see. So 112 divided by 3. So 3 divided into 112. And let's just pick a number. Let's do 5. No, we can do 10. We can do 10. This is a big enough number. 3 times 10 is 30. Simple enough. 3 times 10 equals 30. So we can do minus 30. 112 minus 30. Let's see. I gotta do it like this. Hold on. My math in my head, nope, that doesn't work. That's 2. I didn't have to cross off here. Sorry, I got myself all confused. 82, is that right? I didn't have to do that at all. Let's scratch that out. Because 2 minus 0 is 2, 11 minus 3 is 8. 82. Okay, so that is 10. I can put that 10 over there. Let's subtract 30 again. And I get 52. So far, so good. So we're going to put another 10. We're going to subtract 30 again because we're still, the 30 works. So we can do that. 10. And we get 22. Uh-oh. 10's not going to work because 22 is smaller than 32. So let's choose another number that's really easy. Let's do 3 times 5 is equal to 15. So we'll do minus 15. We'll put our 5 over here. 22 minus 15 is 7. Once again, 7 smaller than 15. So let's do 3 times 2 is equal to 6. 7 minus 6 is 1. So let's add all this together because this isn't 0, but it's okay. So that gives us 20. That gives us 30. And this gives us 35. And then we have 1. So our answer, if 112 divided by 3 is equal to 35, remainder 1. Now, some of the problems might have a remainder. That's okay. No big deal. 5th grade friends, you know that when you have a remainder, this could actually be 35 and 1/3 because we could take that 1 and put it over our 3. If you get into fractions, 4th grade friends, don't worry too much about that. That is a 5th grade thing. But if you want to start practicing, go ahead. Okay. So that is partial product division. And now we're going to flip the page and go to our standard algorithm. Now, I hate calling it the standard method, but that's what I'm going to call it because I don't have another name for it right now. Basically, this is what we want to work towards. This is what we want to do to get there so we can eliminate all the extra steps. So if I have a number and it is 235 divided by 5, I'm going to rewrite it as 5 divided into 235. And we're just going to start going step by step with these top sections up here and working our way down. So first things first, I'm going to cover up these numbers. I'm going to see, does 5 divide into 2? No. So what I do is I put a 0 up there to hold its place, and I move on to the next one. Now I just cover up the 5. Does 5 divide into 23? Yes. And I know that 5 times 4 is 20. So I can do this. I'm going to put the 20 under the numbers that I didn't have covered up, and then I'm going to subtract. 2 minus 2 is 0. 3 minus 0 is 3. And then we bring down this 5, okay? Because now we don't want to cover it up anymore. We need it. Now, for our last one, does 5 go into 35? Yes, it does. Fun little trick. Any number that ends in a 5 or 0 is always divisible by 5. So 35, I know 5 times 7 off the top of my head is equal to 35. So I'm going to put 7 up here. We have 35. 35 minus 35 is 0. So your answer comes to 47. Okay, now I am going to do one problem all 3 ways and kind of show how they grow into each other. So let's see. Let's pick another one. Let's do what numbers do I want to do? I want to do 99 divided by 3. I feel like that's a good number, a good combination of the numbers that I can show all 3 different ways. So let's show you how 99 divided by 3 can be done repeated subtraction way. So if we do 99 minus 3, let's put a tally right here. 1, that's 96. This is actually going to take a really long time. This is just an example of how it can take a really long time. So that's 93, 90, 87, 84. I've done 1, 2, 3, 4. I'm not going to go through and do it, but you see how once you get up here, it can get really long really fast. Like this number doesn't even seem that big, but it is when you're doing repeated subtraction. So let's move on to partial products and see what we would get if we did it that way. So if we do 99 divided by 3, let's do it partial products way. I know, let's start with 3 times 10. 3 times 10 is equal to 30. Nice and simple. So minus 30 would give us 69. That's 110. Minus 30 would give us 39. That's 2 tenths. Minus 30 would give us a 9. That's 3 tenths. Now, I know right off the top of my head, 3 times 3 is equal to 9. So I could subtract 9, get 0, put 3 here. And our answer for this would be 33. Partial quotients, thank you. Partial products, partial quotients. We're doing similar stuff when it comes to that. Anyways, next one, standard method. Let's show you how simple this could be. 3 divided into 99. Cover this up. 3 times 3 is 9. Okay. Subtract it. Bring the 9 down. And then we have 3 times 3 again is 9. Bring it down. 0. Answer is 33. So let's just take a look at this. This one, our repeated subtraction method, takes so long that I just completely gave up on trying to do it. I surrendered. I was not going to subtract it 33 times. I got to 4 and quit. Partial quotients, I kept saying partial products, but partial quotients, you use partial products in partial quotients. You can do it. It's just a little bit longer, but the shortest and quickest way, once you understand kind of what's going on, is definitely the standard method. If you look at it, it is just so much simpler just to do this method. So now I am going to, what am I going to do? I'm going to say, go enjoy your lunch. I will have a math assignment with some division problems up for you. Hopefully I can avoid remainders. I do apologize if they are on there. But yeah, have a great day, and I will see you tomorrow.